Students, delta modulation की बात चल रही है, and we looked at the basic concept of delta modulation and how the delta modulated stream of bits is produced. Now let's go to the slide and have a look at the modulation process in the DM. As you can see, we have got a delta modulator or a DM modulator, and it consists of three components. We have got a comparator, we have got a delay unit. Delay unit is not really important, it just holds the signal until the comparator is ready to do its job. But the two basic components are comparator and the staircase maker. So this is a new concept that we are introducing in here, and that is of a staircase. Staircase signal, आपने देखा था, staircase maker actually constructs that same staircase signal. But let's see why we need it. Students, in this case, the modulation process that you're looking at, it records the small positive or negative changes which are called as delta. और आपकी book में this is represented by a symbol of this. So this delta is, if this delta is positive, the resulting process records a bit of 1. If this delta is going up, same concept that we looked at when we were studying the concept of delta modulation, if the analog signal is increasing, means the delta is positive, then we record a 1. Students, if the delta is negative, we record a 0. Basically, it's the same scientific explanation or DM language explanation of what we went through in the basic concept of delta modulation. Students, in this particular case, there is an additional requirement though. The modulation requires that we have got a base against which this analog signal can be compared. Or students, this essentially means that we need to build a second signal that resembles a staircase signal. And for that, you have got a staircase maker, which creates a staircase signal that we are going to compare this analog signal with. Students, finding the change, once we have got this staircase signal, finding the change or the delta is then just a matter of comparing the input signal with this staircase signal. So you just compare the two, and we do this comparison by using the component that we call as comparator. You can see that in the figure above. I'm going to write it here again. We do that by using a comparator. Now, students, as you can see, the modulator at each sampling interval, it compares the value of the analog signal with the last value of the staircase signal. हम लोगों ने DM के concept को go through करते हुए भी ये देखा था कि it compares the value of the analog signal with the previous value of the staircase signal. Once again, if the amplitude of the analog signal is larger, it increases. The next bit is 1. Otherwise, it is 0. The same concept of delta. Students, one additional point before we leave this modulation process, and that is that the output of the comparator that you're looking at, it also makes a staircase signal itself. So this output here, this is also a staircase signal. Students, once again, if the next bit is 1, the staircase maker, it moves the last point of the staircase signal, which is your delta, up. And if the next bit is 0, it moves the delta down. And as I told you, the last piece is a delay unit, and it's just there to hold the staircase function for the period between the two comparisons. Now, students, कुछ बात करेंगे about delta demodulation की. At the receiving end, we receive this stream of bits. I told you no code words in DM. Bits are sent one by one. So these bits are then received at the receiving end, and the demodulator, it takes this data and it uses the staircase maker again. It uses the staircase maker and once again the delay unit, and as you know, and you're probably well aware of that. Up until now, we need a low-pass filter to smoothen that staircase signal into a replica of our analog signal. So this is just there to smoothen our staircase signal into an analog signal. Students, before leaving this, we will talk about one additional concept, and that is of adaptive DM, or adaptive delta modulation. Students, the scientists and experimentationists, they found out that if we employ different values of delta, if delta is not fixed, then the performance of delta modulation, it goes up. So students, in adaptive delta modulation, the value of delta changes according to the amplitude of the original signal. So our delta is adaptive, and this is called adaptive delta modulation. Students, once again, we have got DM, just like PCM is not perfect. So we will still have some quantization error out here, but this quantization error, let's represent that by QE. This QE for DM is a lot lesser than QE for PCM. Therefore, it makes delta modulation a better choice as compared to pulse code modulation.